Hey guys, welcome back to Math for My Desk. It's been quite some time since I've posted a new video. However, I am back right now, and in this video for y is equal to x to the power of x, I will be finding the derivative of y with respect to x. So this function over here, x to the x, is a function that's obviously very interesting, and obviously when it comes to integrating this, it ends up being much harder. However, you'll find that differentiating x to the x is actually pretty easy. So let's go ahead and start. So the first thing we're going to do is for y is equal to x to the x, we're going to go ahead and take the natural logarithm of both sides. So let's go ahead and do that. So I'm going to take the ln, the natural log of y. And obviously when I do this to the left side, I also have to do this to the right side. So I'm taking the natural log of x to the x. And let's not forget our logarithm properties. This power to the x over here, what I can do is I can go ahead and bring that out here in front. So it becomes x times the natural log of x. So let's go ahead and rewrite that this way. So now I have the natural log of y is equal to x, and this is simply based on the properties of logarithms, which you should have learned somewhere in algebra 2. So we have x times the natural log of x. And so now we're ready to differentiate this. So what we're going to do is some implicit differentiation to be able to find dy dx. So now I'm going to go ahead and take the derivative with respect to x of both sides. So I'm going to go ahead and differentiate both sides. There isn't a lot of space here. I'm just going to do a little arrow. And so let's go ahead and do that. So if you want to differentiate the natural log of y with respect to x, what we're going to do is we're going to go ahead and treat this as the chain rule. So if we take the derivative here of the outside, we end up with 1 over y. The derivative of the natural log of y is 1 over y. And then we're going to go ahead and multiply that by dy dx. This is simply the chain rule. This is an application of the chain rule, since we're differentiating with respect to x, not with respect to y. And so 1 over y times dy dx is equal to, so now we want to go ahead and differentiate x times the natural log of x. So for that, I'm simply going to go ahead and use the product rule. So firstly, I'm going to take the derivative of x, which is 1, and multiply that by the natural log of x. So I have simply the natural log of x. And to that, I'm going to add x times the derivative of the natural log of x. The derivative with respect to x of the natural log of x is 1 over x. And so I can go ahead and simplify this. So I end up with 1 over y dy dx is equal to the natural log of x. And then x times 1 over x is simply x over x, which is 1, plus 1. Now what I'm going to go ahead and do is multiply both sides by y. So because I'm going to get rid of this 1 over y. So I'm going to go ahead and multiply both sides by y. So I end up here with this 1 over y and this y are going to cancel each other out. So I end up with dy dx is equal to y times the natural log of x plus 1. And what did we define earlier? We defined y to be equal to x to the x. So I can simply go ahead and replace this y with x to the x, so that we have everything as a function of x. So now I can finally write that the derivative of y with respect to x is equal to x to the x times the natural log of x plus 1. And this right here is my final answer. I hope you guys enjoyed watching this video, and I also want to say that I'll be making a video soon on using an epsilon delta proof for a limit. And bye, and I'll see you soon.